Welcome everyone to the keynote talk at Coalesce 2021, How Big is This Wave? I'm Julia Schottenstein and I'm part of the product team at DBT Labs, and I'll be your host for this talk. In this session, we're going to hear from Tristan Handy, founder and CEO of DBT Labs, as well as Martin Casado, who is a general partner at Andreessen Horowitz and our investor and board member. The data stack is having a renaissance, and DBT is at the center of it all. I won't spoil any of their talk, but my guess is Tristan and Martin will argue that this wave is pretty big. I'm excited to be here alongside more than 10,000 of you joining for Coalesce. It's this community that powers the movement forward. We invite you to contribute to the conversation in DBT Slack channel, Coalesce Keynote Wave. Feel free to share your thoughts and ask questions, and Tristan and Martin will follow up with folks after the session. So without further ado, over to you, Tristan and Martin.
Thank you, Julia. And Martin, good to have you.
Well, I'm delighted to be here, Tristan.
Are you doing a Peloton workout as we do this session?
That is actually an elliptical. That'll be between meetings.
Let me set this conversation up, and then I think you're going to do most of the talking here. But I get a lot of feedback from folks who have been in the data industry for a little while. They want to talk about the term modern data stack, and they have a sentiment that is something like, we've seen this movie before. And especially for those folks who have invested millions of dollars in Netezza boxes, there's a little bit of scar tissue that is very justifiable. I think of the industry in three phases. Wave one is the data warehouse appliance. Maybe that's early to mid, maybe to late 2000s. And then wave two is the Hadoop ecosystem. You've got companies like Cloudera, Hortonworks, late 2000s to the mid 2010s. So this is like the trajectory that I think we're on. And if these folks that I hear from, they're like, this is just another wave. And the temptation is just, this is trendy, I'm going to sit this one out. But I think that's not the right way to understand this. I think that what we're involved in right now is significantly more persistent than a 5-year trend. And I think that it's going to impact all of our careers and the way the future goes and all of that. The reason for everyone on the line here, the reason I wanted Martin to join us is because he has a unique perspective on technology cycles. Martin's not only a prolific investor in data tech, but he's responsible for creating and commercializing a piece of infrastructure that is now central to the way that the cloud works. So I'm hoping to steal some of the lessons from your earlier journey, Martin, in seeing how much they apply here and what we're up to. So maybe we can start out here. What's software-defined networking?
So software-defined networking. So software-defined networking is an umbrella term for viewing networking as a software problem as opposed to an ASIC problem. And it now covers many things, but the way that I like to describe it is, say 20 years ago, if you were to build a network for, running a very covert intelligence organization, you'd buy boxes from Cisco or Juniper, and then you'd plug them in, and then you could configure them with a CLI, and that's where you were. But if Cisco and Juniper hadn't anticipated the type of security posture that you needed, because they don't normally sell to covert intelligence agencies, there's kind of nothing you could do. There was no real programming interface. And this was very different than, let's say, operating systems at the time. So in operating systems at the time, you could go in and if you had Linux and you could muck around and you could program things that were just specific to you. We actually had a lot of evolution in operating systems at the time because of that, but you couldn't do that with networking. There was no model. So software-defined networking is an umbrella term, is how do you make networking as flexible as, say, operating systems or distributed systems so that you can program them and make them fit for whatever task you're interested in.
Tell me the story. How did you get involved?
My first job, I'm a failed physicist. My first job out of college was working at a national lab, and I did computational physics. I worked actually in the weapons program at the time. There's a lot of modeling going on of nuclear weapons. And I was there when 9/11 happened, actually. And so it was weird because I was in this anachronism holdover from the Cold War. Right? It was nuclear weapons, which kind of weren't that relevant. And there was a very different posture for the government at the time, which is now the terrorist threat. And because I had a lot of the clearances, they moved me from being basically a distributed computational scientist to the intelligence community where I worked on the war on terror. And so my background was very much like operating systems and distributed systems. I wasn't a networking guy. And so I alluded it to before, which is I was responsible for these kind of like very deep kind of covert infrastructure buildouts that we were doing. And it was just so obvious that you didn't have the same type of flexibility that you would have, let's say, if you were just trying to do this on just a computer. So I moved on from that. I worked in the intelligence community from Afghanistan through Iraq, and I moved on to do my PhD at Stanford. And there I just focused on this problem. And at the time, it was very interesting because at the time, so this is like 2004-ish, networking, which kind of grew up in the internet, networking gear kind of grew up in the public internet era, was being pushed into all sorts of different areas that it wasn't really built for. So it was like being pushed into like large data centers, which were pretty new at the time. And it was being pushed to build like large mobile networks, which were pretty new at the time because the iPhone was coming out. And so you had this kind of old architecture that was now being used for all these different use cases that we hadn't really anticipated. And so it's just a good time to rethink. Maybe you could redo the architecture so make it a bit programmable. And so that's what we worked on and ended up spending the next 15 years of my life on it.
So the part that feels really resonant with what we are working on here, maybe like certainly the cloud data warehouse is programmable in the ways that matter. I feel like when you start to talk, when we've talked about this before, the control plane and the data plane, this split of like, how do you make something that's fundamentally on a box scale to many boxes is the problem I think that we started to solve in the 2012, 2013 time horizon. Is that the like fundamental unlock that you were working on at Stanford, you and others?
Here, I actually think it's probably going to be helpful for you and I to step back a bit and be like, why are we even in a third wave? And then I think we can unpack a little bit about what's going on, because I actually think that like markets create the technologies almost, not the other way around. And I think that's very much what's going on here. So here's how I like to say it, which is, okay, I'm an investor and there's many things I don't know, most things I don't know, but like one thing I do see is a lot of companies. And here's the biggest shift, I think, certainly in infrastructure in the last forever, since the beginning of compute, which is today, let's say 5 dog walking companies come in, different ones, to pitch me over a couple of months. And what they do is they pair dog walkers with dogs. Now, in the lab, before, say, 5-6 years ago, the ways that they would differentiate on are going to be things like, oh, like we scale, we're like seamlessly mobile. It's going to be a lot of like how they write the software, like we're very fast, we're very flexible, et cetera, like that. That's basically the pitch most companies had, because software as a big global distributed technology wasn't very mature. So it was very much the focus of the questions and the answer. Today, if these 5 dog walking companies come in, almost all of the differentiation, maybe all the differentiation outside of brand, is how they handle data, right? It's what is the matching algorithm between dogs and people? How do we predict pricing? What about fraud? What if you aren't really a dog walker? There's all of these things that you actually differentiate. And none of them are like actually core software. So I think that if you want to come up with a mental model of how the world has changed, and this is why this isn't just like the third wave, like the other wave, it's like the world has changed and now like data is catching up, is today, if you're building a company, especially an app, like a SaaS app, the way that you differentiate is through how you manage data. But the data ecosystem just doesn't have the level of maturity of the software ecosystem, because in the past, so much of the differentiation was software. Does that make sense? So I would say, very similar to my SDN journey, the world now is demanding more of the technology. So in the SDN journey, it wasn't that like we sat in a room and we came up with, here's a great way to do technology. Nothing we came up with was fundamentally new, but the world was ready for it. It was like, we're taking these networks that were built to connect whatever universities and we're putting them in war zones. That's not going to work. Oh, we're taking these computers that were built to connect scientists and we're trying to build Google out of them and putting them in data like that. That's not going to work. And so the world now demanded more. And as a result, we had to sit back and think, okay, what can we do to evolve that? And again, this is what I think is happening with data.
So wait, was that the beginning of a sentence or in the end of a sentence?
That was the end of the sentence, but I was going to go transition to that. But please ask your question. And I'll get there.
So I'm with you, and you're ruining the punchline a little bit because I want to get there. But one of the things that I think that folks in data are a little bit used to is that we use this technology that it like then doesn't have more layers that sit on top of it. So there's not more layers that sit on top of data warehouse appliances that happened in 2000s, right? Like it was the end of the line. But my understanding is that whether or not you're going to take credit for doing anything fundamentally new, the technologies that you were involved in building in this time frame now no longer sit at the top. They've now had stuff layered on top of them. And that is, I think, one of the most interesting questions about the next 5 to 10 years for the modern data stack. Like what other stuff is going to get layered on top of data ingestion, data warehousing, data transformation?
100%. Totally. Yeah, I've got this fundamental belief. I've been now in systems basically my whole life, right? As like an independent like researcher, as a entrepreneur, whatever. And my pure belief is like layers never go away. We just add on top of them, or sometimes we delaminate them. Like you can almost think of all of computing as you take a mainframe and then you just delaminate it. And so I'm going to use another analogy, and I'm going to back up into what you said. So it turns out when markets expand, you normally take kind of fixed function things, and then you pull out pieces of that. And you can build entire industries or companies on that. And my favorite example is what happened to the auto industry. So in the early 1900s, there was a Ford plant called the Rouge River plant. It was in Dearborn, Michigan. And this is early on when there wasn't like a huge market for cars. And like literally in this plant, in went like coal and rubber and iron ore, and out came cars. Like it was like that was the sophistication of the industry.
It was the mainframe.
It was the mainframe. It was literally rubber was going into this thing, whatever. But what's interesting is if you could look at that car and you could almost predict the future. Because if you look today, now like the automotive industry is this multi-trillion-dollar industry, and it is composed of multiple tiers of suppliers, and even independent kind of like bolts and belts and this and that can be entire companies. It's created this entire industry. And so this is very much what happened with networking. And then I'm going to get to the data part, which is, so what did we do? Networking was never really a distributed systems problem. It was always, you just assumed everything was going to be eventually consistent. You assumed full distribution, and that's what you built. And so what we did is we almost took like a single switch or a single router. And we're like, what happens if you delaminate this and pull this apart and you can scale this to the size of the globe? And then independent people could build independent parts of that and add value to that. It's almost this delamination thing that happens, right? Now, does it get rid of any switches or routers? Of course not. There's still switches and routers today. If you're building the most kind of crazy crypto startup where you're creating your own whatever, you're still using switches and routers. It's not like they go away, right? And so the same thing I believe is happening to the data industry, which is one way to think about it is there is this platonic ideal of I'm going to have this cloud data warehouse in the sky, and it's going to have all of the tooling for it, and it can do all of this and then whatever on top of it. But the reality is because the market is getting so large, you're going to have to delaminate that. You're going to have to pull that apart. And then independent, what you'd consider tools or even features of tools are going to become entire companies, and they're going to be pushing areas that we can not think about. But in order to do that, you need to really think very carefully about things like open source, because it is a strict requirement. Everything that we did in the early networking days was open source because you need an industry to move. You need open standards. You need to think about interfaces. You need to think about how these tools. This is why DBT is, because in many ways it's this glue that stitches together this massive expanse phase for the data industry.
Talk about your product being used inside of Google data centers. That story blew me away.
Okay, so let me just talk about what we did to begin with. So it used to be, if you're building a data center, you grab a bunch of switches and then you connect all the switches together to make effectively one large switch, except for it really was just a bunch of different switches. Then if you manage them, you'd have to go and you'd have to manage all of these different switches. And by the way that networking algorithms work is if whatever one link failed, then it would flood all the links to everybody else. And it was like really optimized for these densely connected graphs that were like local networks or the internet. It wasn't built for that sort of density. And so what we did is we decided to build a general operating system that would connect to multiple switches or routers, and then you could program for whatever you wanted to. And so what we did is we were programming it. So we built this kind of operating system that would connect to all the switches and routers, and we were programming it to make virtual data centers so that like network management was similar to management of a virtual machine. You could create things virtually and move them around, etc. But it was a general operating system. And so other companies picked it up for other things. And so Google early on picked it up to use in two ways. One of them to actually run like the data center fabric, so they could abstract it as a single switch and actually optimize failures, and also for their backbone. Now, remember, this is a very thin, almost interface layer, at which they built really fancy stuff on top of it. But you can actually, even if you look up Onyx, ONIX, that's the paper, but it also mentions some of the use cases.
So I think that this mirrors a lot of my own experiences in the story of our early days. Like the DBT was originally created to be a tool that was used by me and Drew and doing consulting work. And I, as much as I'm like a Richard Stallman fan and like the classic open source and all this stuff, I had like never gone on an open source, open standards journey myself. And so there have been these points in time over the past 5.5 years where DBT, now we haven't made our way into the like core backbone of Google data centers yet. So that's still pretty cool. But DBT shows up in all these like really unexpected places. And I just, in the early days, you could never have convinced me that it would spread in the way that it has. And so I guess maybe my question for you is just, do these things take on a life of their own? Like what dynamic is actually going on here?
So I love it. It's funny, like when you do something, new and you watch it take hold, like the signs, the indications that things are happening. So I remember when I first got my first SDN spam, I was like, what? You're like, and then I remember
somebody was trying to sell you SDN.
No, it was like one of these conference spammy things where they're like, oh, come to this like online conference, like whatever SDN. It was just like they're using it as a buzzword. And then I remember when companies started talking about it. I remember when people started putting it on their LinkedIn. And I think actually, I just want to go to the previous comment I had, because I think it's so relevant, which is so often we look at technologies and we're like, oh, this technology has X and Y, and therefore it's great, and therefore people use it. But I strongly believe the reality is the market need evolves, and sometimes it creates vacuums. And then the thing that's best suited to fill the vacuum gets pulled into that vacuum, and that's the expanse that you see. It's not like you woke up in the morning one day, Tristan, and like, I want people to get DBT spam. It was like I didn't wake up in the morning and say I want people to get, or I want people to have some hokey conference or this or that or the other thing. But it's like there's an actual need, and then it's our job as a community and it's our job as an innovator, so as quickly as possible make that technology fit kind of the market needed as it's evolving. And so I love like looking at these kind of almost like pulsar level indications of the need. And I'll tell you, and this is one of the reasons why DBT is so interesting. I would say across industries, if you want to get a sense of like the size of the data movement, I would say across A16Z, probably the most activity and entropy outside of crypto, which is really pretty significant, is data. So just the sheer number of companies in the data space that are being created and are evolving and are raising is unlike anything I've ever seen. And it's fantastic. And I'll say a good number of those are actually very focused on open standards. They use DBT. They're focused on open source. So I do think that it's also an accelerant to filling this market need.
Let's go back for a second to your car analogy. Now this has become canon for me. Ben Evans, he used to be at A16Z. He wrote a post about how you could predict the car, but what you couldn't predict is Walmart and McDonald's. And when you start to look at the history of the car, you actually get into this, okay, first we have to figure out how to make cars, great. And then, yes, we need to build a lot more roads. But then what suburbs were going to look like, or the fact that we all wanted like a hamburger that was consistent across our entire like 12-hour road trip, no one would have guessed that was going to happen. And so I just use that as backdrop. I want to move the conversation into what stuff you think might get built on top of all of this tech that we're building, because that's what's going to make it long lasting. And I think ultimately we don't know the answer to that, but I've got some hypotheses. I wonder if you have any hypotheses.
Okay, so yeah, this is a lot we can talk about. I actually try not to presuppose the future in many ways, because it tends to take these kind of wild, fascinating shapes that we can't predict, per your point. But I do think it's worth saying something to tee up this conversation, which is I'm not sure that what we're creating with data isn't like almost an entirely different discipline. I mean, like that, the level of change may be that. And let me explain that really quickly. And then I would love to hear your thoughts and then we can noodle on it. But I just want to tee up one thing, which is software is very much an engineering discipline, right? It's like you live and die by abstraction and modularity, and you can actually rein in complexity by good programming practices. You're like, I create this library, I create this interface or this API. And so it's very much kind of an engineering project where you have a project that you want to do, you want a system you want to build, and you break it down into pieces, you rein in the complexity that way, and then you go ahead and build it. And it's not clear to me that the very nature of the problems we're tackling with data, at least some of them, are of the same order. In many ways, dealing with data is like dealing with like the complexities of the universe. There is no way to abstract it. It's just fundamentally very complex, and we're trying to look for answers. Now, I just want to give you an anecdote that happened very recently to me, just to give you a sense of this. And so I was speaking with one of the top AI people who works in NLU, which is building large models. And they're, of course, looking for kind of AGI, generalized artificial intelligence. And he was telling me, he's like, hey, listen, I've been doing this. I did this at OpenAI. I've done this at Google. I've done this for a very long time. And what's really interesting is you could train these like big, huge models, and you can train them to like learn natural language. But what's really weird is then you can take that same model and you can play a video game with it. Like I'm talking about moving pixels on the screen, not just like listening to language. And then he got kind of philosophical. Maybe there's like these fundamental rules of the universe that like these models are learning about, and the universe isn't that complex. It just requires a lot of computation to figure out. So that was the general trend of the conversation. So the point of this anecdote is not to say we can do AGI. The point of this is listening to him was not listening. It wasn't listening to an engineer. It was like listening to a scientist philosopher. This is someone, it sounded like talking to a physicist. And so I think that when we talk data, there's data infrastructure. Like I'm an infrastructure type of dude, right? Like I build software that scales. There's the infrastructure for the data, but then there's the data itself. And once you enter that domain, I think we're better like leafing through a science fiction book than we are leafing through like an analyst report. I really do feel like this unlocks almost the next level of system building. And so to tee up the conversation, and I'd love to hear your thoughts. I just want to make the point that we could be seriously.
No,
Chris,
I'm just imagining Isaac Asimov as like the next Gartner analyst.
Exactly. We could be on the verge of like almost like a new discipline with a new type of person, etc.
Yeah. Okay. And so that gets into one of my three thrusts, and maybe it's so much bigger than the other two. I feel like the place that we sit at today is there's still this big divide between the ML people and the analytics people. And by and large today, you're here talking to the analytics people. We probably have like friends in ML, but mostly we're not like sitting on that side of the wall ourselves. It feels to me like for the professional success of many of us here, we would all love to be able to go maybe not all the way down, like fully submerged into the data science ML world, but go in to a certain extent. And often it is actually like the dichotomy of the technology stacks that actually keep us out of there. I feel like the bringing together of those two stacks is a major part of this trend that I want to see.
Yeah, totally. I think the analyst ML labels are basically where you came from, and you're both going the same place. I just do. And so to go back to the SDN as maybe a bit of a learning journey on this, in these kind of early days of the creation of an industry, there's just so much chaos and everybody's confused. And that's actually a good measure of the health of something. Almost, the more chaos, the healthier. The more entropy, the healthier, for sure. It just suggests that they're growing and people don't have time to optimize. As soon as people are like really worried about like the specific definition of this or the specific stack of that, they just have too much time on their hands. They're not running after like the,
Sure.
I think it's absolutely the case. And so this is, in these growth phases, people are just at a dead run. And so for those of you that don't know, Matt Bornstein, who works with me, Jennifer Lee, who also works with me, and we spent about a year just talking to practitioners who know way more than we do about the quote unquote new data stack. And listen, when I say new data stack, I literally don't, this isn't some VC buzzwordy thing. It just turns out that people are building bigger systems and they're using new technologies. And we just wanted to know what that was like. And so one of the big questions we wanted to answer, Tristan, was exactly this question you raised, which is there like this big difference between analysts and ML folks and what's going on and et cetera? And we wrote this report and we try to reconcile it all. But I got to tell you, my actual takeaway that we didn't put in the report, it's like you're hearing it for the first time here, is it's just a mess out there. Like people haven't a clue.
Yeah.
If you took a Venn diagram of all of the answers we got, you'd end up with the null set, like this strictly the null set. But I don't mean to ramble on about this because I just think it's so germane to the question you asked. It is clear that the goals are very similar. And whether someone calls themselves ML or an analyst, because that's where they came from, it really is about building systems that extract value out of data. And so I honestly believe that this is all going in the same place. And the analysts have a career path that's just as complicated, just as complex, just as deep, just as sophisticated. I just think that they just come from a different, and I, honestly, like, I hate to say it, but probably a more disciplined background.
While we're talking about the mess of technologies that people use and the null set of overlapping, there have been, and I'm not honestly in this camp, but there are voices who talk about this as a problem. Things are too complicated, and the kind of specter that gets invoked is the like Oracle or whatever, these like behemoths who have acquired their way towards a way to do everything beginning to end in a single product. And that is, maybe that's simpler from a buyer perspective, certainly. And maybe you can just attend all the same trainings and you know how to do the whole field. I don't know. I'm resistant to that. Do you think that's a way to resolve this complexity?
Listen, I think entropy is endemic in growing systems, full stop. So either you're part of a growing trend or you wait until it collapses. I don't think there's any way around it. And I want to be actually very clear about what I mean. Every once in a while, the industry, listen, the industry is like a big amoeba and it sends these pseudopods out, like whatever. And every once in a while, it hits like this vein of food, and it's going to go there and it's going to mine that and it's going to grow. And when that happens, because our industry is so innovative, everybody focuses on like, how do I build the best solution here for whatever it is? And so you get all of the chaos and all of the effort and all the, this is exactly how SDN was. It was being applied to things that it should never have been applied to, for sure. Like people are like, I'm going to use SDN for building ad hoc networks for like phones, like when you're hiking and things like that. It just didn't really apply. And so you just have these massive chaos where you have these expanse phases because the growth opportunity is in new areas and you're exploring, and that's where the value is. There's a reason why markets value growth, is because that's where value increases. And so in any market that has a lot of expansion, you'll always, and if you're interested in actually growing with the market and taking advantage of what's new, you have to be part of this kind of chaotic landscape. Then what happens is markets slow down, but they've actually staffed up towards growth. So you've got all of these people and you've got all of these products. That's when you actually start to see consolidation. This is where you're like, oh, there's nothing new to do. Tie two things together. Like, I'm going to improve the user experience, et cetera, et cetera. And I do think that everybody listening and every organization has to decide where on this curve they are. Like, listen, I'm an investor, but I'm also like, my entire life has been like basically category creation, bleeding edge innovation. So man, throw me in the deep end. Like, I want all the chaos. I want to be in the middle of the maelstrom. I want stuff not to work. I want stuff not to fit together. That's just why I got into tech to begin with. On the other hand, there is a very practical stance here that uses like blueprints that have emerged that are based on traditional technologies, but flirt with the new things, where there are examples out there where people use it very successfully. There's talent that you can hire into. And that's a great way to understand these new technologies and use them, where like maybe 20% is a new stack, but it's based on an old stack. And then listen, if you don't care about being part of the wave, sure, you can use laggard technology and you can join the Museum of Computer Science Past, and we'll visit you when we come through.
All right, so I have two more. And I want to leave new platform for application development till the end, because I know that we could run out the clock on that.
Right, yeah.
But the next one I want to talk about is what I am in my head calling pervasive analytics. Not necessarily a like fundamental increase in capability, but an increase in connective tissue and an improvement in user experience. So like the thing that I feel like is, how do we get an order of magnitude increase within a given company in their usage of whatever cloud data platform that they're using? And I think that is less about what are the kind of core data workflows that you like need to do, you're probably doing them already. It is actually a question of like, how do you get data into the hands of every knowledge worker in the organization and get their decisions to just be like, not you're conducting science in the same way that like you're not conducting science when you like look for recommendations on OpenTable. Like it's just a part of the workflow. There's a lot of like people thinking about this. I'm one of them in my Substack. Everybody's got a Substack today, and I'm one of them. What do you look at companies who are trying to push this future?
Yeah, for sure. So again, I like historical analogs. I strongly believe that the closest analog to data is software, and I think it's that size too. I think it's arguably bigger because I do think it kind of straddles, like I said before, the engineering and then potentially the science too. And most of the people I would imagine that are listening to this have actually seen software come of age because it happened in the last 10 years. Software was traditionally something that businesses would build and then maybe you'd put on a PC. And it wasn't until maybe 2009 that we all became massive software consumers. I probably, I don't know, in the last couple of years spent $10,000 on software, 99 cents at a time on my iPhone, right? And that's a funny thing to mention that way, but the reality is we've matured everybody in the workforce as a software buyer, and that means that now you can have these what you call prosumer apps, which you don't have a sales force. They look like consumer apps, but they actually do real productivity and real work. And the users, most importantly, know how to buy them, download them, and use them effectively. And I would say this has been massive in kind of productivity gains in the entire industry. And I absolutely think that data is going to go through the same renaissance, which is we forget just because it's easy to forget, we've just all become software consumers, really. Like we actually really weren't before. If you think you were like you're buying your app, like your game for Windows 95, you weren't really like a software consumer. Now we're software consumers. Buying an app is something we do every single day. I think what's going to happen forward is we're all going to become data consumers because it is so relevant to our personal lives and it's so relevant to every job function we do. But the industry really hasn't caught up to provide us with kind of the tools in order to do that. And I'm using almost a consumer analogy, which, I don't think we have to, but I just think that it will, from the consumer to the prosumer to the worker to, of course, the back-end analyst, this is going to be part of our daily routine. And we're just at the very cusp of it. Another sign of the big growth in data.
I want that world to exist. And I think of the App Store, the iPhone App Store too, when you go from like this high level imagination of like how a user experience could work down to, oh shit, what are all the things that we're going to have to build in order to like make that possible? But like,
Totally.
we're probably not there yet, honestly. And it's not just like a compute and storage and moving the data around and all this stuff. It's also, that if I have never been a senior person in an IT organization, but I can imagine that if I were, that would terrify me a little bit. Lots and lots, because the common element that all of these things will need is like access to your data.
Oh, for sure. Yeah.
We've got to make that safe. I assume that's next project number one if we want this world to come into existence.
I don't even think we understand what it means to build a company that's entirely data focused. So absolutely, like compliance is a big issue, security is a big issue, but there's also things like liveness and correctness. And again, I think this is all a part of why this may even shift disciplines. If you have a piece of software and you press a button, you normally know what that button's going to do. So you've got pretty deterministic output. When it comes to data and analyzing data, you've entered this realm of interpretation, which is we want to expose a bunch of data and people make decisions based on that data, and we're going to improve the accuracy of that over time. But there's just this kind of massive evolution on the tooling, and then also evolution on how we educate users on what that means. And so not only is it, to your point, system regulatory compliance, is also a massive kind of education and just changing the way that we think. And so this is why this is a trend that will, I think, last on the order of decades, not.
What's going to be my question? Like, this doesn't seem, 5 more years and we'll be there, which to a certain extent, maybe this actually feels a little bit harder than the software
100%.
change it.
Exactly.
Well-
But here's the good news. Here's the good news. Okay. So listen, here's why everybody here should feel very confident that, listen, if you choose to do this for the next 50 years, you're in the right place. So let's say, Tristan, you and I in a few years, we really care about climate science and we're going to help fund a company that is going to solve like a lot of these things. It's very much a data problem. And so there's a company that like pops up that's really focused, or maybe it's a nonprofit effort that really focuses on predicting what are the key contributors to climate science, great predictive model, very much a data thing. It's something that we work on. Very different discipline. A lot of folks will be involved. If you come up with an answer, let's say you come up with an answer and like that, like fundamentally change how we think about climate science, you know what we'll do? We'll be like, oh, that's great. That's one app. Then we'll go off and go after, I don't know, like water pollution, or we'll go after something else. It's literally one app. Like in the limit, the things that you can apply data to is basically the natural world. And so I think, yes, there's going to be this, it's true. There's going to be this massive kind of shift into how we think about data. And then I think we're just going to start applying it to these broad things, and we can tackle huge problems and then move on to the next. So yes, exactly to your point. I do think that this is a multi-decade thing.
So I know that my last question for you was actually going to be, what's your takeaway for all the people who are here today? And I think that you just gave the answer to that question. The career path, everybody like defines career ladders for their analytics organization. And what you won't see is get promoted, become a founder, tackle climate change. But like I have personally found that my data skills have been incredibly relevant to think from first principles as you navigate all the uncertainty involved in starting a company. So I actually don't think that feels really normal and natural to me. Not that I'm necessarily inviting 10,000 people to tomorrow go pitch you, but I think that that's a thing that will happen.
Yeah, I think the most important thing to understand for people that are listening to this that aren't in my position, and it's hard to actually get a broad view in the day-to-day. What's funny is I did a bunch of technical work. I founded two companies. I was an exec in a very large company. Like when I left, it was a $600 million run rate product. I've done all of those things, and I didn't really understand how the industry worked until I had this position, because you see so many companies. And so in some ways, it's almost like sampling the industry. And two big takeaways. The first one, and I've said it before, but it's worth reiterating, which is the biggest growth area right now in all of the industry is data, for sure. And it's not because it's buzzy. It's not because the VCs created this. No, it's because there's just a fundamental need, and people are smart and they address needs. And the need is the market. And it's what I said before. It's because today, if you're building any system in tech, the way you differentiate is through data. That's how you differentiate. Everything else is relatively mature. It's hard, but it's an engineering problem. And so just know that if you're in data, this is great. And then I would realize that there isn't this schism. There's almost this false schism we've created between like analysts and ML and this and that. The second thing I think is important to know is we're really all heading in the same place, which is like, how do you build a discipline and an industry around data that's at the size of software, and probably much better because it's going to shift. And so no matter where you are, I think you continue to focus on that. And yeah, absolutely. Listen, if you're quite interested in doing something very big, my email is open, as they say.